Guys, so here we have another problem dealing with modeling real world data. And we're given a table, and on the left we have year, and on the right we have restaurants in thousands. Okay, so as we can see here, as the year increases, right, the number of restaurants increase as well. Okay, now in the past we were able to determine what type of function we are dealing with here by testing either the differences or the ratios. And in order to do that, you need to have either evenly spaced x values or evenly spaced y values. Okay, and in this case, we can see that we do not have evenly spaced x values, and we also don't have evenly spaced y values. Okay, so for this particular problem, all right, we're unable to test what type of function this may be. And this is where your graphing calculator is going to come into play. So in this example, I'm going to show you how to use your graphing calculator to do something called a regression analysis. And that's going to show you what type of function is going to best model this data. All right, so let's go ahead and pull up our graphing calculator so I can walk you through this process. All right, guys, so here we are in our graphing calculator. And in order to do a regression analysis to determine what type of function is going to best model this data, we have to go ahead and enter the data into our calculator. And in order to do that, we're going to go to the Stat button right here. So hit Stat. And then you're going to go to Edit. So hit Enter. And then we're given this table here where we have L1, L2, L3. We're only focusing on L1 and L2. L1 represents your X values. L2 represents your Y values. So I'm going to go ahead and start plugging these in. So we know that we have 1991. Okay. So I'm going to represent that with just 1. Okay. So in this case, we know that my starting point, okay, of this graph is going to be at 0, which will be 1990, okay? So just keep that in mind. Your starting point will be 1990. All right, so here's my first point. I have 1, which is 1991. Then I have 1993, so I'm going to represent that with 3, okay? 1997, I'm going to represent that with 7. 1999, I'll represent that with 9. Okay, 2000, we represent it with 10. And 2004 will represent with 14. Okay, and now to the right, again, these are the number of restaurants, these are our Y values, and these are in the thousands, so just keep that in mind. So we have 100, and again, I'm just pulling this right off the table. 108, 169, 237, 280, and 380. Okay, so now that we have this data in here, we can go ahead and go to second and quit, go to y equals, and then you want to make sure that this little plot here is highlighted. So if it's not highlighted, go up, click enter, and make sure it's highlighted. That's going to go ahead and plot your points. So let's go ahead and do that. So we're going to hit graph, and then you can see that nothing is showing up. So if you go to zoom and you go all the way down to where it says zoom stat, that's going to zoom in, okay, on what you just put into that stat table. And there we go. So we can see, okay, that, well, this isn't really linear, right? It could be a quadratic, a cubic, right? So those are some possible options that we have. Now let's determine how we're going to find that function. So we're going to go to second, quit. We're going to go back to stat. All right, and then we're going to go over to calc. Okay, and then, okay, well, we determined, right, here are options that we can test. We determined that, well, it's probably not going to be linear, right? It didn't look linear. So why don't we go ahead and try quadratic? This is talking about a quadratic regression. This is going to test if a quadratic function fits this data. So we're going to try this guy right here. So if we hit enter and hit enter again, we're given these lists of values. Now, what you are looking at right now is this r squared value, okay? What that r squared value tells you, it tells you how well the model that you just generated, okay, is going to fit your data. You want to get that as close to 1 as possible. So right now, we are very close to 1, right? We have 0.98, so this is pretty good, okay? Okay. And we call that, okay, the r squared value, the coefficient of determination, all right? And again, you want to get that as close to 1 as possible, right? The closer to 1, the better your model will be, okay, at, well, modeling your data. Okay, so let's try another one. Let's go to stat again. Let's go over to calc, and let's try a cubic now. All right, let's see what happens when we do cubic. Again, so we'll hit enter. And now I have 0.99, right? So this is even better. So I think I'm going to stick with a cubic here. So look what you're given here. You're giving a list of your values, A, B, C, and D. All you have to do is plug it into, right, what you're given. So AX cubed plus BX squared plus CX plus D. You're just plugging in those values. Okay, and you don't have to include all these placeholders. Obviously, if you do, the more accurate it will be. Okay, but we will round those values. So why don't I go ahead, put this into my calculator, and then I'll be right back. All right, guys, so here is my data again, and all I did was I went to y equals, and I just went ahead and created my function. So I rounded to the nearest thousandths, okay? And what we're going to do now is the plot is still turned on, which we want to leave on so we can see, okay, how well this is going to fit. All right, and then here's our function. So we're going to go ahead and hit graph. Okay. And there we can see it modeling our data fairly accurately, okay? And again, this is starting at 0 on the x, meaning 1990, right? And then it's going, okay, over to the right as it increases in years. Okay, so you can go ahead and test this out. So let's go to second calc, and we'll go to value, right? And let's see what happens when x is equal to 10. We know that will be 2000, right? So if we go and type that in, well, we get 271, right? And if we look at our data table for 2000, we had 280, right? So this is fairly accurate. And again, this is in thousands, okay? So again, this is how you go ahead and model real world data and how you can use your graphing calculator, okay, to do this process. Okay, and that is it.